Hello. Test. Okay. Test. Dah terbalik pula, kena letak poket sebelah sini. Apa dia berbelit-belit macam ni? Ni sebelah sini kan? Ke sebelah sini? Dia punya wire sebelah sini sebelah sini lah. Hello. Test. Dah macam dengar dah.
Test. Check sound 1 2 3 test. Assalamualaikum test. Okay.
Test. Assalamualaikum. Tak ada tengok muka lagi. Muka belum keluar. Test. Silent. Saya ingatkan nak letak macam ni. Lagi susah
Susah. Tak sini.
Susah.
Sana bawah ni.
Tanda ni. Yang tadi tu boleh letak next terus. Macam ni kan. Sini. Tapi lepas habis first ni lah.
Angkat.
Lepas habis first nanti saya tolong angkat. Lepas tu saya terus adjust.
Check. Sekejap.
Okay. Terus balik muka tu.
Hai, saya Nur Ain binti Muhammad Bahrul. Saya merupakan jurutera elektrik di Makmal Penyelidikan Elektrik Grade.
Assalamualaikum, nama saya Muhammad Afiq Betan Bicik dan saya merupakan seorang jurutera di Makmal Penyelidikan Struktur Konkrit dan Alam Sekitar.
Assalamualaikum, nama saya Siti Nur Azila binti Khalid. Saya salah seorang jurutera di Makmal Penyelidikan Mekanikal.
Hai, nama saya Syaran Kumar Nagendran. Saya adalah salah seorang jurutera di Makmal Penyelidikan Geoteknik.
Saya Muhyiddin bin Rosmani daripada Makmal Penyelidikan Jalan.
Saya lebih cenderung kepada bidang mekanikal kerana saya tertarik dengan idea Tuan M berkenaan kereta terbang. Di Grade terdapat 10 makmal kejuruteraan mekanikal, antaranya adalah kejuruteraan otomotif yang mana kenderaan diuji dengan menggunakan chassis dyno. Daripada pengujian itu, kita dapat mengenai pasti nilai torque dan juga keupayaan prestasi sesebuah kenderaan. Selain itu, kita juga dapat mengetahui sama ada proses pembakaran bahan api di kenderaan itu mencapai tahap optimum ataupun tidak. Kita juga mempunyai peralatan pengujian yang mana ia dapat mengesan kerosakan melalui kod kerosakan. Daripada result yang dipaparkan, kita boleh menumpukan pembaikan pada masalah tersebut.
Bidang kejuruteraan ini juga merupakan bidang paling asas masalah yang berkaitan dengan aktiviti harian kita.
Dengan menjadi seorang jurutera, saya akan dapat membina sesuatu yang berguna untuk masyarakat. Contohnya seperti bangunan, jambatan dan jalan raya. Namun demikian, terdapat juga jurutera yang melakukan penyelidikan.
Dengan penyelidikan, kita akan mengetahui penyelesaian bagi sesuatu masalah dalam bidang kejuruteraan. Penyelidikan juga membantu kita untuk menambah baik spesifikasi suatu teknologi kejuruteraan itu. Antara kajian yang sedang berjalan ketika ini di Makmal Penyelidikan Jalan ialah kajian penggunaan getah jenis letek dan kaklam sebagai bahan tambah dalam turapan jalan. Selain itu, kami juga menjalankan kajian garisan jalan jenis high performance thermoplastik dan cold ply plastik. Kajian all weather cold mix sebagai bahan penampal pothole. Kajian crack sealing dalam merawat keretakan pada permukaan jalan.
Saya memilih bidang ini adalah disebabkan saya ingin berkongsi pengalaman dan kemahiran saya terhadap pembangunan negara. Saya berminat terhadap penyelidikan adalah disebabkan kecenderungan saya untuk melihat sesuatu perkara yang lebih mendalam. Apabila kita menjalankan sesuatu kajian, kita akan mengetahui punca, faktor dan akhir sekali kita akan melihat kesan terhadap sesuatu perkara yang kita kaji.
Dengan kejuruteraan, kita dapat mencipta banyak benda yang baru, inovasi-inovasi yang baru dengan idea-idea yang kreatif yang kita sudah ada. Kita dapat menyelesaikan dan membantu masyarakat kita.
Berjaya sebagai seorang jurutera di Makmal, dia memberi saya peluang untuk saya membuat penambahbaikan kepada apa masalah yang ada dekat dalam dunia ini. Contohnya adalah seperti manfaat kepada alam sekitar.
Antara kajian yang kami jalankan adalah mengkaji bahan buangan daripada kuari, iaitu kuari das, untuk menstabilkan kawasan yang mempunyai tanah lembut.
Kita boleh gunakan dalam konkrit sebagai bahan ganti untuk memberi kekuatan kepada konkrit tersebut. Selain itu, ada juga kajian penggunaan foam konkrit bagi menghasilkan struktur yang ringan dan kuat. Buih yang ringan akan dicampur di dalam konkrit dan kita akan gunakan untuk kes-kes yang memerlukan beban yang rendah dan juga memerlukan kekuatan.
Untuk kerja forensik di approach bridge yang sangat biasa kita dapat lihat di kebanyakan jalan akan terdapat endapan tanah di kawasan tersebut, dan melalui kajian yang kami jalankan di Makmal, kita telah melaksanakan satu kajian menggunakan PU injection iaitu polyurethane yang dapat menyelesaikan masalah endapan ini.
Pelbagai aktiviti yang dijalankan di Makmal Penyelidikan Elektrik antaranya adalah glow wire test yang dijalankan di Makmal Diagnostik dan juga fotometrik yang dijalankan di Makmal Gonya. Kajian yang sudah saya jalankan ini iaitu kajian pengaruh warna terhadap pencahayaan lux, di mana kajian yang lebih mendalam dijalankan untuk melihat kesan dan faktor terhadap pencahayaan lux.
Kita juga mempunyai makmal bahan yang mana terdapat beberapa jenis mesin, antaranya adalah 3D dan SEM mikroskop. Daripada situ, kita dapat menganalisis masalah-masalah pada permukaan dengan lebih terperinci.
Kajian-kajian yang dilakukan ini sangat menarik sebab ia memberi kita satu pengetahuan baru terhadap perkara yang kita tak pernah teroka.
Di samping itu juga, kita akan lebih memahami sesuatu teknologi itu kerana kita terlibat dengan pengumpulan data dan analisis dari peringkat awal.
Perkara yang membuatkan saya seronok dalam menjalankan tugas saya ini apabila saya dapat menyelesaikan tugas saya dengan penuh kesungguhan dan mencapai target yang saya inginkan.
Saya memilih bidang geoteknik ini kerana sejak dari zaman saya belajar di Politeknik dahulu, saya telah mula untuk melaksanakan kajian projek akhir tahun saya. Dengan itulah cetusnya minat saya terhadap bidang geoteknik ini.
Kerja dalam bidang penyelidikan sesuatu yang menyeronokkan kerana melalui penyelidikan kita akan jumpa sesuatu penemuan yang baru. Profession jurutera ini merupakan profession yang mencabar.
Nasihat saya kepada generasi baru supaya mereka menukar pandangan mereka terhadap jurutera. Kita tidak hanya mereka bentuk dan membina, tapi kita juga ada melakukan penyelidikan yang boleh membantu menyelesaikan kepada suatu masalah.
Profession teknikal ini haruslah diceburi oleh semua generasi baru kerana ia dapat meningkatkan kebolehan diri kita dan juga untuk masa depan negara.
Harapan saya kepada generasi muda, ayolah kita sama tanamkan minat dalam bidang kejuruteraan.
Untuk berjaya dalam profession ini, kita perlu mempunyai minat yang mendalam dan sentiasa ingin belajar sesuatu yang baru kerana bidang ini sangat berkait rapat dengan perkembangan teknologi semasa.
Ayuh kita sama-sama menerokai bidang kejuruteraan seiring dengan perkembangan globalisasi bertaraf dunia.
Together we change the world with engineering.
CREAT provides the facilities and platform for engineers to venture into uncharted territory through training and research. Research and development is the generation of new knowledge which will bring JKR to new levels.
Penjagaan kesihatan adalah antara perkara asas dalam kehidupan manusia. Untuk keluarga dan individu yang kurang berkemampuan, hospital kerajaan bagaikan suatu rahmat dan tanda tidak mengabaikan kesihatan rakyat. Bagi mereka yang berada di kawasan luar bandar, sebuah jambatan yang baik dan selamat adalah satu rahmat. Penghubung yang selamat dan selesa amat memberi kesan kepada mereka dalam menjalani kehidupan seharian. Tak kala hujan di malam hari, kejadian seperti pokok tumbang amat membahaya. Ketika kita sedang tidur lena, mereka di sana menarik dahan berpeluh hujan sambil menahan sejuk, semata-mata untuk memberi kehidupan besoknya lancar tanpa mengganggu rutin laluan pengguna jalan raya. Rantaian dan kelangsungan hidup di sebuah ekosistem tidak seharusnya terputus walau atas nama pembangunan. Eko biadab sebagai jawapan agar mereka di sana dapat terus hidup di habitatnya secara bebas dan alami. Sebelum berlakunya tanda hukum yang bakal merangkap nyawa dan keceriaan keluarga, cerun yang dikenal pasti dan berisiko akan diselenggara dan ditambak dengan baik demi keselamatan dan keselesaan semua. Ruang pendidikan tidak terhad di kawasan Semenanjung sahaja. Sekolah hybrid didirikan di kawasan pendalaman yang mana kosnya melebihi kos sebuah sekolah. Anak-anak yang sebelum ini kurang bernasib baik dapat belajar dengan adanya tenaga elektrik. Untuk memastikan kelancaran acara paling bersejarah, CKR telah dipertanggungjawabkan untuk menyelenggara stadium negara agar seluruh dunia dapat menjadi saksi peristiwa kemerdekaan negara. Nikmat jaringan jalan raya kini amat manis jika kita tahu sejarahnya. Waktu itu mereka bukan sahaja bekerja di tengah hutan belantara, malah bertaruh nyawa diancam bintang buas serta serangan Taliban komunis. Hikmat pasal banjir besi JKR ditubuhkan untuk memberi bantuan keperluan asas wang ringgit serta tenaga kementerian untuk membawa harapan dan semangat baru kepada bangsa. JKR sentiasa berusaha untuk menjadikan infrastruktur dan persekitaran yang lebih baik sekaligus menjadi pembangkit utama dalam pembangunan sosial ekonomi negara. Setiap generasi pastinya menikmati kemudahan dan kemajuan yang dibawa JKR seiring dengan kehidupan mereka.
Assalamualaikum and a very good morning to the ladies and gentlemen. This is to inform you that the opening ceremony will be starting in 10 minutes. Kindly be seated. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and good morning to the ladies and gentlemen. We are delighted to welcome you to the International Seminar on Forensic Engineering organized by Center of Excellence for Engineering and Technology CREATE, Public Works Department Malaysia, with leveraging the fourth industrial revolution, IR 4.0, to create future opportunities and manage challenges in forensic engineering as it teams.
Ladies and gentlemen, this seminar is designed to bring together engineers, industry players, academicians, and practitioners to share their experience and knowledge and exchange views on innovation, challenges in the industry, and future opportunities related to the forensic engineering.
It is an honor for me to introduce and welcome the guests at our table, Director General Public Works Department of Malaysia, Datuk Engineer Haji Zulkifli bin Haji Sulaiman, Senior Director of Public Works Department CREATE, Engineer Razia binti Wahab, Directors, all Deputy Directors, and welcome to all our invited speakers, ladies and gentlemen, to this international seminar on forensic engineering. First of all, my name is Muhammad Zakwan bin Zabri, and this is my partner.
I'm Siti Nur Azila binti Khalid.
We will be your master of ceremony for this seminar.
Before we proceed, we would like to invite all of us to stand up for the national anthem, Negaraku. Thank you, and kindly be seated. Next, let's watch a safety video briefing by the Center of Excellence for Engineering and Technology, Public Works Department of Malaysia.
Pusat Kecemerlangan, Kejuruteraan dan Teknologi JKR CREATE. Talimat keselamatan ini akan disampaikan oleh Encik Muhammad Hairudin bin Hamdan selaku Pegawai Keselamatan dan Kesihatan CREATE.
Selamat datang ke Pusat Kecemerlangan, Kejuruteraan dan Teknologi JKR CREATE. Sila berikan perhatian sepenuhnya terhadap talimat keselamatan ini. Talimat keselamatan ini mungkin berbeza dengan premis atau lokasi yang lain. Jom. Sebagai peringatan, tuan-tuan dan puan-puan diminta untuk mengambil tindakan seperti berikut sekiranya berlaku kecemasan. Ingat, jangan panik. Ini tindakan yang betul. Beri keutamaan kepada orang kelainan upaya dan wanita mengandung. Tuan-tuan dan puan-puan, sila tinggalkan barang-barang yang besar dan berat seperti beg, buku dan sebagainya. Tuan-tuan dan puan-puan yang berada di Dewan Kred, sila bergerak ke tempat berkumpul mengikut laluan kecemasan berikut. Sila bergerak ke tempat berkumpul yang telah ditetapkan. Sila kekal berada di tempat berkumpul sehingga keadaan disahkan selamat oleh Pegawai Keselamatan dan Kesihatan Kred. Sekira berlaku kecemasan, jangan gunakan. Bye.
Honorable guests, ladies and gentlemen, before we begin, allow me to read the main agendas of the seminar. We will begin with an welcoming speech from the Senior Director of Public Work Department Kred, followed by an opening speech by our Director General, Public Work Department of Malaysia, Datuk Engineer Haji Zulkifli bin Haji Sulaiman. After that, there will be a keynote speech by the Senior Director of Public Work Department Kred, Engineer Razia binti Wahab, followed by the core of the seminar, which is presentation by 11 representative speakers from the Public Work Department, industry and academician. This seminar will be held for 2 days, which is scheduled to be end up by tomorrow evening.
Distinguished guests, participants, ladies and gentlemen, without any further ado, I would like to welcome Engineer Razia binti Wahab, Senior Director of Public Work Department Kred, to give her welcoming speech. Welcome.
Bismillahirrahmanirrahim. The Honorable Datuk Engineer Haji Muhammad Zulkifli bin Haji Sulaiman, the Director General of the Public Works Department of Malaysia, Datuk Engineer Haji Ahmad Reza bin Gulam Rasul, the Deputy Director General of the Public Works Department of Malaysia, Infrasector, Datuk Engineer Haji Habali bin Ibrahim, the Deputy Director General of the Public Works Department of Malaysia, Building Sector, Engineer Dr. Lim Chia Ching, Senior Director of Civil and Structure Engineering Branch, Acting Deputy Director General of the Public Works Department of Malaysia, Specialist Sector, ladies and gentlemen, honorable participants. Assalamualaikum and a very good morning. Firstly, all praise be to Allah Subhanahu wa Ta'ala for His grace in making this live webinar event possible amidst the COVID-19 pandemic. Welcome to the International Seminar on Forensic Engineering. The International Seminar on Forensic Engineering is organized by the Center of Excellence for Engineering and Technology, CREATE, Public Works Department of Malaysia, and will be conducted virtually from 5th to 6th October 2021. To accommodate the government's call for social and physical distancing requirement due to the COVID-19 pandemic. I am honored to announce that the theme of this seminar is leveraging the fourth industrial revolution, IR 4.0, to create future opportunities and manage challenges in forensic engineering. During this two-day seminar, participants will listen to presentations by experts in forensic engineering on topics which include innovations, challenges in the industry, and future opportunities related to forensic engineering by leveraging the principles of the fourth industrial revolution 4.0, such as big data, Internet of Things, cloud computing, system integration, intelligent system, and robotics. Ladies and gentlemen, forensic engineering is the application of engineering principles and methodologies to the investigations of failure or performance problem related to materials, design, and structures which cause casualty, injury, or economic loss. This process is founded on the scientific and engineering methods which are fundamental to the solution of most engineering predicament related to, but not limited to, civil, structural, geotechnical, mechanical, chemical, and materials engineering. With the increasing challenges and complexity in fieldworks and in conducting investigations, the forensic engineering field has no choice but to leverage the advancements of digital technologies to enhance engineering judgment and improve the effectiveness of the public service delivery system. Ladies and gentlemen, we are proud to announce that we have invited 11 highly respected speakers in forensic engineering who will enlighten all participants on current issues in forensic engineering across the globe. Dr. Ashok Krishnan from Japan will speak on INSAR technique to monitor deformation, while Dr. William Chiang Wai Lam from Singapore will deliver a presentation on cloud computing. We also have presenters from the Public Works Department of Malaysia, namely Engineer Dr. Fairul Zahri bin Muhammad Abbas, Dr. Muhammad Nizar bin Abdul Rahman, Engineer Technical Specialist Nur Naimah binti Esa, Nur Azlan bin Abdullah, and Engineer Ilyani Yazrin binti Abdurrani, who will be sharing their experiences and knowledge through topics related to achievements, issues, and challenges in the field of forensic engineering. Next up, we will listen to Engineer Parmat Singh from the industry on creating future opportunities in forensic engineering and challenges of IR 4.0, Mr. Zarul Azral from Khairi Consult, Sendirian Berham, will share on parametric study of abandoned cut slopes. We have also have academicians, that is Professor Engineer Dr. Raizal Saiful Nas bin Muhammad Rashid from University Putra Malaysia, and Dr. Payam Shafiq from University Malaysia, who will talk on advances in construction materials and related technologies for retrofitting and rehabilitation of deteriorated built environment. In conclusion, the latest technology that moves in line with the changes of the IR 4.0 revolution industry needs to be utilized by all parties, as it can help increase work productivity in the field of forensic engineering. These technology advances can also produce a new skilled workforce, thus increasing employment opportunities. I wish to thank the Director General of the Public Works Department Malaysia, the Honorable Datuk Engineer Haji Muhammad Zikri bin Haji Sulaiman, for his willingness to officiate the International Seminar on Forensic Engineering. Lastly, on behalf of the organizing committee, I hope that all of you will benefit from this seminar and that you have a good time and opportunity to connect with the experts through their lectures and presentations. My utmost congratulations to the Secretariat and committee members of the International Seminar on forensic engineering for making this seminar a reality. My gratitude also goes to all invited speakers, for without whom this seminar would not have been successful. With that, I thank you.
Thank you, Engineer Razia binti Wahab, for the welcoming speech just now.
Distinguished guests, participants, ladies and gentlemen, as the host of this seminar, let's hear the opening speech by the Director General Public Work Department of Malaysia, Datuk Engineer Haji Zulkifli bin Haji Sulaiman. Let's the video begin now.
Bismillahirrahmanirrahim. Yang bahagia Datuk Engineer Haji Ahmad Reza bin Ilham Rasul, Deputy Director General of the Public Works Department of Malaysia, Infrastructure. Yang bahagia Datuk Engineer Haji Habali bin Ibrahim, Deputy Director General of the Public Works Department of Malaysia, Badan Sektor. Yang berusia Engineer Dr. Lim Cha Ching, Senior Director of the Civil and Structural Engineering Branch, Acting Deputy Director General of the Public Works Department of Malaysia, Special Sector. Yang berusia Engineer Razia binti Wahab, Senior Director of the Centre of Excellence for Engineering and Technology, PWD Oakridge. Senior Directors, Honourable Participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Let us give thanks to Allah Subhanahu wa Taala for His grace and favour. We are all able together at this auspicious event. I'm honoured and delighted to welcome all of you to the International Seminar on Forensic Engineering with the theme Leveraging the Fourth Industrial Revolution, R4.0, to create future opportunities and manage challenges in forensic engineering. Please allow me to also congratulate the Organising Committee, the Centre of Excellence for Engineering and Technology, JKR, Oakridge, for organising this international seminar amidst the COVID-19 pandemic and giving me this privilege to officiate this seminar. Ladies and gentlemen, forensic engineering is the application of engineering principle and science used in the investigation of failures, ranging from serviceability to catastrophic. And this includes the investigation of materials, products, structures, or components that fail or do not operate or function as intended, causing personal injury, damage to property, or economic loss, which may eventually lead to legal activity in both civil and criminal. Furthermore, forensic engineering helps forensic engineers understand what went wrong or what did not perform to expectations as we strive for better design, more reliable operation, and safer structures. These activities require tools and technologies, which includes optical scanners, electron microscopes, spectroscopy, X-ray radiography, and tomography to assist them in their investigations. Ladies and gentlemen, the Fourth Industrial Revolution, R4.0, is a digital transformation characterized by integration of smart enabling technologies such as artificial intelligence, cloud computing and analytics, machine learning, robotics, Internet of Things or IoT, and automation to redefine the traditional way we operate, which will lead to higher productivity and improve quality. Moving forward, the forensic engineering field must adopt these digital technologies to enhance engineering judgment, conduct accurate and precise analysis, and improve the effectiveness of public service delivery system, hence making the world a safer place for all of us. In tandem with Malaysia's 4IR policy, the Public Works Department of Malaysia is proactively embracing and leveraging these digital technologies to enhance its delivery system, create new opportunities, and manage the challenges faced in forensic engineering. In this regard, I am pleased that this seminar is designed for experts to share their experiences and knowledge, action ideas on innovations, challenges in the industry, and future opportunities related to forensic engineering. I look forward to an exciting seminar which brings together experts and renowned speakers from within the country and abroad who represents the government, industry and academia. Undoubtedly, it is essential for us to keep up with the development in forensic engineering throughout the world, where views and ideas from experts can help strengthen and reinforce our forensic engineering skills and competencies in this field. We are proud to announce that we have invited two highly respected speakers who will enlighten us on the technological advances in forensic engineering outside of Malaysia. Ashok Krishna from Suspective Incorporated from Japan, he will speak on ground deformation monitoring using INSA technique. And Dr. William Chiang Wai Lam from Sekian Banking System from Singapore will deliver a presentation on from ground to cloud computational geotechnique and forensic engineering. We also have presenters from the Public Works Department of Malaysia, namely Engineer Dr. Fairuz Zahri bin Muhammad Abbas, Engineer Dr. Muhammad Liza bin Abdul Rahman, Engineer Teknologis Nur Naimah binti Isa, Nur Aslan bin Abdullah, and Engineer Eliani Yazrin bin Abdul Rani, who will share their experiences and knowledge through topics related to achievements, issues, and challenges in the field of forensic engineering. I strongly believe this sharing of information and knowledge is important as it helps to disseminate lessons learned from issues and challenges for us to improve public service delivery, enhance departmental expertise in forensic engineering, database custodian of issues, and technical solutions which can be used to mitigate future risks or disaster recurrence of similar failures. In addition, the seminar features presenters from the industry who will share and discuss significant new development and technological advancement that will impact the future of forensic engineering, investigation, and solutions. In this regard, Engineer Puan from RNC Technology Center will speak on creating future opportunities in forensic engineering and challenges of IRA 4.0. And Mr. Zarul Azri from Khair Consult Sudan Berat will share on parametric study using forensic method on abandoned cut slopes on a road project. I am confident these presentations delivered by experts in the industry will contribute to the body of knowledge derived from field exploration and analysis by leveraging appropriate digital technologies in the quest to improve the way we tackle issues at site, planning of technical or engineering solutions to the issues, as well as developing best practices. The role of academicians are vital in enhancing local expertise in the field of forensic engineering. Professor Engineer Dr. Razal Saifunas bin Muhammad Rashid and Dr. Brian Shafiq from University Petroleum Malaysia and University Malaya respectively will impart comprehensive knowledge on the advances in construction materials and related technologies for retrofitting and rehabilitation of deteriorated built structures. Ladies and gentlemen, I am hopeful this international seminar on forensic engineering will be a repository of knowledge in contributing to the engineering community and build a collaborative platform for global networking as we move towards sustainable development imperatives for a better world. This seminar is envisaged to involve our minds with some take-home messages pertinent to improving our delivery system, essentially making us more responsible in protecting life, livelihood, and structures. Once again, on behalf of the organizing committee, I hope you will all benefit from this seminar and have an enjoyable time networking with the experts from the field of forensic engineering. Lastly, my utmost congratulations to the Secretariat and committee members of the International Seminar on Forensic Engineering for making this seminar a reality. With this, I hereby declare the International Seminar on Forensic Engineering, leveraging the fourth industrial revolution at 4.0 to create future opportunities and manage challenges in forensic engineering, open. Assalamualaikum warahmatullahi taala wabarakatuh. And thank you.
Thank you to the Director General of Public Work Department of Malaysia, Datuk Engineer Haji Zulkifli bin Haji Sulaiman, for the opening and inauguration speech just now. Next will be the keynote speech delivered by the Senior Director of CREATE Public Work Department, Engineer Raziah binti Wahab.
Ladies and gentlemen, please welcome Engineer Raziah binti Wahab to the stage.
Ladies and gentlemen, honorable participants, Assalamualaikum and a very good morning. I would like to thank the organizing committee, the JKR Center of Excellence for Engineering and Technology, CREATE, for inviting me to deliver the keynote speech for the International Seminar on Forensic Engineering. Well, I am pleased to be here and be involved in the discussions around the theme leveraging the fourth industrial revolution, IR 4.0, to create future opportunities and manage challenges in forensic engineering. So this morning, I'm going to speak on the overview on forensic engineering. My presentation today will go through introduction to forensic engineering, disasters, goal of forensic engineering investigation process, technology, and finally the conclusions. What is forensic engineering? As I mentioned in the opening speech just now, it is the application of engineering methodologies to the investigation of failures related to materials, design, and structures which cause casualty, engineering, or economic loss. It is a multidisciplinary process to investigate and report the cause of failures. It may involve not only the technical department, but also the, for example, fire department or chemical department if it involves in explosions or fires. The study of materials, products, components of structures which fail or do not operate or fail to function as intended. When we speak about forensic engineering, what comes to our mind? It will take us to disaster events happening around the world. For in Malaysia, we will remember these events. On the 11th December 1993, the Highland Towers collapsed, which occurred due to a major landslide caused by heavy rains that burst diversion pipes, resulted in 48 deaths. The Highland Tower complex was built in phases from 1978 to 1982, and it consists of 3-block apartments. Due to the disaster, one block collapsed, but the 2 other blocks was not usable anymore. It is left vacant. On the 29th August 1996, mud flow near Pos Dipang Orang Asli settlement killed 44 people. In December 2008, Bukit Antarabangsa landslide, damaging 14 bungalows, killed 4 people and injured 15 others. In December 2016, landslide at Serendah, causing property damages, and 300 people need to be evacuated temporarily. On March 2021, collapse of overhead bridge at SUKE Highway when an overloaded trailer hit the scaffolding that supported a segment under construction. This caused collapse that trapped a factory van with 5 people inside who were on their way to work. Alhamdulillah, no life was involved in this disaster. In September 2021, recently it happens, landslide along the Jalan Kemensah Heights due to the movement of the underground water causing the soil structure to slide. However, no death was reported. This event caused property damage. And on the 18th September 2021, landslide along the Jalan Persekutuan FT 185, Section 43, Jalan Puslim Lodging, due to landslide causing road closure. In the global event, disaster, in November 1940, Tacoma Narrow Bridge collapse. This collapse is due to aeroelastic flutter. On October 1944, in Cleveland, Ohio, gas explosion left 131 killed, 225 injured, and almost 700 homeless. It is due to gas explosion because of leak in a storage tank. In May 1968, the Ronan Point collapse of entire corner of the building due to a gas explosion at the 18th floor, causing 5 deaths and 17 injured. In December 1984, chemical disaster due to gas leak at the Union Carbide India Limited pesticide plant in Bhopal, causing at least 10,000 people deaths and 500,000 people exposed to methyl isocyanate. In this September 2001, the famous 9/11 disaster, the collapse of the Twin Tower, World Trade Center, New York. Some of the failures that need forensic engineering are due to deficient or faulty design, material defects, that is due to steel corrosion, concrete carbonation, and some others. Enemy cause also due to weather conditions, flooding, fire, accidents, and overloading in terms of bridge. Yeah? Okay, the statistic shows the bridge collapse, the source from Wikipedia, that has occurred from the year 19,000 to 1949, 26 bridge failures, 1950 to 1999, 77 bridge failures, and from 2000 to present, 129 bridge failures. For structural failure, It is due to inability of component, structure, or facility to perform its function. Failure does not necessarily involve collapse or rupture, because if we detect it earlier, then we can take mitigation before a disaster happens. Non-conformity with design specifications or deficient performance, and unacceptable difference between the expected and observed performance. As for functional failure, it may involve compromise of intended usage of structure or facility. For example, excessive vibration of the floor, roof leaks, inadequate air condition, and poor acoustics. Poor site selection and site development errors. Maybe the site selected at area which have high water table. Programming deficiencies. That means wrong data will input, and then due to data analysis, wrong output is received due and caused to the design errors. Construction mistake, procedural non-compliance, material deficiencies may be due to material selection or material changes that does not conform to their specification. And also it may cause due to operational errors. In terms of disaster and forensic engineering, who are the clients? The owners, developers, and tenants, public government agencies, contractors, designers and material manufacturers, attorneys, plaintiffs in litigation, that is the injured parties, defendants in litigation, design, in terms of design, construction, maintenance, or operation. The goals of forensic investigation have to be determined at the beginning of the forensic engineering. So we have to know the cause of failure to improve or prevent similar events from happening. And is also to gather physical or non-compliance evidence, mainly for verifications and validations of statements with evidence. The goal also is to assess the damages in products, materials, or structures in order to evaluate costs of repair or retrofit. Also to find the party or individual responsible for the failure. And finally, to produce investigative reports as supporting documents for legal purposes and judicial proceedings. This slide shows the forensic investigative process. From the start, we have to determine the objectives of investigation, and then we gather background information on the case, including related documents such as newspaper, news from the TV, from the media. Then we conduct preliminary site visit to draw up investigation plan and to do visual assessment. Then we have to form investigation plan and also the team for doing the investigation. And then we have to do the comprehensive study on all available documents and information on the case. Then we have to go back to the site to do detailed site investigation, field tests, and sample collection. All the data collected then have to be analyzed, and we develop conclusions and opinions, including discussions. Finally, we prepare the report. This report can be used to mitigate or to do some and also it can be also used for litigation. The report, where trustworthiness of forensic investigation, it can evolve if various threats can exist when conducting forensic investigations and affect the reliability on investigation findings. It can be general biases of human mind. Sometimes we use the faster decision system to make decision without performing the proper analysis. This can affect the report, the trustworthiness of the report. Human errors due to lack of skills or mistakes that occurred from ignorance of the correct way of doing things. And also other errors arises from instrument error, statistical error, or method error, which may affect the conclusions. In terms of technology with forensic investigation, recent technological developments make it possible to perform more robust studies and gather more reliable evidence. Technologies help reduce human errors, improve data quality, analyze information and evidence faster. For example, of new technologies, sensors wireless sensor network, smartphone technology platforms which can retrieve information at any desired location and time. Forensic 3D imaging to help document and support investigation following fire and explosions, structural failures, and construction disputes. In site where access is very difficult, we can use drone to help us in capturing and identifying complex damages in challenging or unsafe environment involving landslides or mudslides, earthquakes, or building collapses. In conclusion, forensic engineering is the application of engineering methodologies in investigating failures related to materials, design, and structures. Forensic investigation also, more often than not, have been carried out in challenging and dangerous sites, which require the help of highly trained experts and equipment and technologies. Innovations and technologies need to be developed to help provide robust field solutions and more efficient laboratory processing or analysis of evidence. Therefore, triple helix approach to solving forensic investigation between academia, innovation companies, and forensic experts is critical to discover the fit for forensic purpose technology. With this conclusion, I end my presentation. Thank you very much.
Thank you, Engineer Raziah binti Wahab, for the keynote speech just now. Dear ladies and gentlemen, we are now going to have our morning break 10 minutes. Please note that after the break, we will continue with the first presentation.
I would like to remind the audience, during the presentation, the audience may post the question on Facebook Live comment page or YouTube. The question will be forwarded to the speaker during Q&A session. Thank you. Ladies and gentlemen, we have come to the core agenda of our seminar. Our first speaker today is Engineer Parnam Singh from RNC Technologies in Berhad. He will be presenting a paper entitled Creating Future Opportunities in Forensic Engineering and Challenges of IR 4.0. Without further ado, please welcome Engineer Parnam Singh.
Thank you very much, ladies and gentlemen. A very warm welcome to all of you, and for those who are following us on FB, a very warm welcome. I'd like to make a short announcement before I proceed. For those of you who wish to probably request for slides after my presentation, I have to actually categorically mention here that because I've signed a non-disclosure agreement with the holders of the sources of information that I have actually put on the slides, I therefore would like to apologize if you may not be able to get access to the slides that I'm going to share. With that, allow me to begin my presentation for today. Again, a very warm welcome to all participants and those following us on FB today. I have actually simplified my synopsis. Of course, it was a very long synopsis, so I thought I'll just simplify because they say simplification is the elixir of life. So I have actually condensed my long synopsis into just these few sentences, and it basically revolves around the challenges that we are facing today with regards to our structures, which seem to be deteriorating faster than we can respond. Today, we have difficulties in responding to the rate at which structures are actually undergoing deterioration. We also have a chance now to look at how artificial intelligence through digitalization can transform and help us overcome this problem. And the question will always remain, are we prepared and ready to embrace artificial intelligence in advancing forensic engineering? So ladies and gentlemen, for the presentation today, I'll take you through this pertinent question about the presentation. It's not about what happened, classic cases of forensic failures. It's not about lessons learned or collection of failures, but it is all about what we need to know, what we need to do, and how we need to do it. This will be the main focus of my presentation today. And the outline actually spells out 5 areas that we will be going through, starting from the introduction to the conclusions. And of course, there will be a question and answer session after this. But in analyzing the presentation outline, I have actually put it in 3 different areas. The first one would be on problems, the second one will be on challenges, and the third one will be about opportunities. I have been quite fortunate in actually conducting clinical lessons in forensic engineering for engineers all over the country today. And during my lessons with them, I try to excite them by telling them that what Robert T. Rate has mentioned in his book, The Vulnerable Structures of the 20th Century will provide bread and butter to the forensic engineers of the 21st century, which is very true today. What we see today is a culmination of what has actually happened many, many years ago, and this is what we are seeing. And this is something that excites our young engineers. They all want to become forensic engineers after reading this. And also, when I emphasize on the word errors, I've underlined the word errors here. It goes to show that the cause of our problem today is because of our past errors. So the errors of yesterday provide bread and butter to the forensic engineers, and the errors of today will provide bread and butter to the forensic engineers tomorrow. Now, this is actually stated by Robert R. Rate in his book, and he has defined forensic structural investigation as engineering investigation to determine the causes of failures and also rendering opinions. But this is only one half of what we think forensic engineering is all about. Moving on, this comes together with the definition, and it says that it is also giving testimony in judicial proceedings, and that is how we define forensic structural engineering. Now, this is the area that I want to actually discuss today. Our real challenges, the problems that we are facing today is our inability to actually stand up to sometimes be able to actually explain why or who caused the problem, or who was the root, or what caused the root cause of the, for example, a failure or a collapse. This is a typical example of a failure, and this is exactly what you see when failures occur. Typical example of a bridge failure. We will come to this as we move along. And finally, just to quote Robert R. T. Rate again, he says that structural failures are not just accidents nor acts of God, which we all know, and it is the cause of human error. Now, ladies and gentlemen, I have been underlining human error here. Error is the key word that I want to emphasize now. And as I move along, I'll take you through this model, and this is what is called a cause-effect model. This model has been crafted over many years in understanding the problems with structures and what is the real cause of failures. It all starts from an error. If we have an error and if we do not correct the error, if it goes uncorrected, then it becomes a mistake. If someone makes an error and if there's no one to actually supervise his or her work, it becomes a mistake. And in the event the mistake goes uncorrected, it becomes a defect. It leads to a defect. And a defect doesn't lead to a failure immediately. It will also transform itself to become a fault so long as it is uncorrected. So it goes through this phase, and then it translates into a fault. And lastly, if the fault is uncorrected, it eventually becomes a failure. And the relationship between error and failure is nothing but the cause and the effect. The effect is the failure, the cause is the error. So if you have understood this model that I have actually crafted over the years, and analyzing the entry of forensic engineers, on most occasions, forensic engineers enter at a point in time where failures have occurred. And it is actually too late. Forensic engineers must realize that they've got a bigger role to play today. The entry point should be somewhere here, before the failure occurs. I will illustrate this model with two examples of real case failures in order to emphasize on the problems forensic engineers are facing today. Let's look at the current practices in forensic investigations. I will take you to Genoa. This was a bridge in Genoa, a motorway bridge which collapsed in Genoa, Italy. Genoa is actually located close to the shorelines, northwestern part of Italy. And because it is close to the sea, it is obvious that any structure which is built close to the sea would be vulnerable to failure. Now, this is a brief outline of what actually happened on 2018, the collapse of Morandi Bridge in northwestern Italy, which killed 43 people. And it was reported that the root cause of the collapse was attributed to faulty design, construction, and lack of maintenance. So these are some of the keywords again: faulty design, lack of maintenance, and this is exactly what Robert Rate has actually mentioned just now. It is because of neglect. And as the report goes, it is dated 22nd December 2020. This is the aftermath of the collapse. The bridge, a section of the bridge actually collapsed. And these are the remains, and when an analysis was done to identify the area which was actually damaged by the collapse. That's marked in the red. And summarizing the findings, these findings have been actually extracted from reports which have been published, and these are not speculations. So I will go through to actually share with you what are the underlying factors that caused the collapse of the bridge. No follow-up action taken, although Morandi himself, who was the designer and architect of the bridge, he had actually seen some defects due to airborne pollutants and saline air in 1979. The collapse happened in 2018, meaning that there was a problem with the bridge in 1979, very, very long before the bridge collapsed. These were precursor symptoms which were not taken care in the beginning, and no follow-up action was taken. And as a result, because of corrosion, a section of the bridge collapsed. And lack of willingness on the part of relevant parties to intervene at the appropriate time was another factor. Lack of willingness meaning that they dilly-dallied, no action was taken, and to restore the integrity of the bridge. And later, Imbesi, who is an architect by profession, confessed in a documentary that he observed cracks and evidence of corrosion when the bridge was just about 20 years into its service life. Meaning that it was evident that eventually there would be a catastrophic failure with the bridge. Now, going back to the design of the bridge, of course, I'm not a design engineer, therefore I do not wish to actually implore and explore further about how it occurred, but to have a bridge with only 2 cables supporting it, and when the cables did not do their job because of the environment, there was lack of maintenance, and as a result, they had problems. So although there was an attempt to repair the cables, it was just like putting one cable on top of the other, and which served no purpose. Alternatively, it could be if the bridge would have been actually secured by some tendons or some cables more than what was actually provided. So as the bridge we see after the collapse, and today the good news is the bridge has been replaced, and this is a brand new bridge. Now, ladies and gentlemen, I take you back to the model that I've shared with you earlier. The cause was an error. The error was neglect. The error was, there was a mistake. There was an error. The mistake was the error wasn't corrected. It led to a defect. The defects were seen. They were a precursor. But nothing was done. It was all about probably money that could have been affected, that they didn't want to invest in the bridge. And lately, the bridge succumbed to failure, and the failure was related to corrosion damage. So now the cause was the error, and the effect was the failure. Okay, moving on, ladies and gentlemen, another classic example happens to be a bridge in Taiwan. Was a bridge and completed in 1998. And just for your information, this bridge collapsed, unfortunately, on the 1st of October, not very long ago. Now, this is a classic case of a bridge which has got cables. Quite strange, the cables are actually lying on the road, if I may see. And this is actually a very vulnerable structure, simply because we have vehicles running on both sides of the road, and there could be an accidental damage that can occur at any point in time. So what actually happened to this beautiful bridge, which looks splendid by the night? And from the seaward, a photograph taken from the seaward shows the elegant shape and the design, but it eventually collapsed. It happened on the 1st October 2019. Ladies and gentlemen, today is 2021. We are in 5th October. The date today is 5th October 2021. So not very long ago. So it should be pretty fresh in our memory. And the accident occurred at precisely 9:30 a.m. Now, this is, of course, a graphic that has all been extracted from reports. Forensic engineers sometimes, when they present reports, they have to be very careful in actually citing the source where they get the information from. It cannot be something that they assume or they predict or they speculate. So therefore, whatever information that I've shared here today is all from official sources. So this was the aftermath of the collapse. And in summary, the accident occurred on the 1st of October 2019. 6 people died. And it was the first single arch bridge that was hung by cables in Taiwan. And if I may actually draw your attention to this part of my finding from the report. It is not my finding, but my finding from the report. It says the report says, It's not that Parnam Singh says. It says report say that there was evidence of expansion joint failure. Now, this was the precursor symptom for a disaster. So when an expansion joint fails, we always take it for granted that it is because of wear and tear. But not knowing that the bridge was actually undergoing severe distortion, fatigue in the cables. And it was also pointed out that rusty cables were treated and protected, but corroded cables were not replaced. When steel rusts, it is okay to treat and protect steel, but if steel corrodes, then it requires replacement. That is the difference. So as forensic engineers, we will need to distinguish between what is rusty and what is corroded. This is the bird's eye view of the bridge, and it is very clear that although the concrete part of the bridge was pretty intact, the arch part, but it broke at the joints. So meaning that the bridge had actually experienced some kind of fatigue, especially the cables over the years. And could it be because of lack of maintenance? Because there was difficulty in carrying out maintenance, be the cause of this collapse. Again, I would like to refrain myself from making any kind of conclusions here. And I will make reference to what has actually been written in reports, official reports. So this is how the bridge looks like and the condition of the cables. And despite the fact that the bridge was vulnerable to any form of collapse, a number of construction projects were undertaken using this bridge, of course, on the other side of the island probably, or the other side of the port. And according to the report as of December 2020, which is not very far from here, it still says that we are still waiting for the official investigation report. Ladies and gentlemen, forensic investigations cannot be done overnight. They need time. We need time to establish the facts. Not only the facts, but we need to establish the truth. Facts are different from truth. A fact is an assumption, which is an accurate assumption, but a truth may be different. The real cause is certainly different. In summarizing my second case failure here, according to reports again, Taiwan Transportation Safety Board says it does not rule out construction faults and overloading. This is their findings. And there was evidence to suggest that the vertical cable at the center of the bridge snapped first. So I have underlined, I will not read what actually happened. It also says that there was a typhoon that struck a day earlier. Now this is where we are going to get to. When structures are vulnerable, they are located in an area which is prone to attack not only by the forces of nature, but by mistakes or errors made by human beings, there's very little that we can do. And the question again remains, something interesting that was also stated by Robert R. T. Rate in his book. He says, could advances in design, sophistication, and construction methodology. Sometimes we want to take building or construction to the next level, but in doing so, are we actually sacrificing, okay, maintenance for the price of aesthetics? Now moving on, we all know, it's fresh in our memory, the recent Surfside condominium collapse, which occurred on June 24, 2021, which is not very far from where we are today. And that amounted to almost 98 deaths. I will not go into the details of this particular case because the site is still under investigation. I don't want to speculate. I don't want to make my own assumptions. There are many YouTubers who have already made their assumptions. They have already given a verdict what actually caused the failure. So I believe that forensic engineers should not jump to conclusions. So therefore, I will still render this as a site under investigation. Therefore, if there's a chance again, if we meet again, probably then we could probably get some results from the investigation, and we will try to learn from failures. So this was the Miami condo collapse. There have been a lot of young engineers or someone who is in the field who would want to use this slide and then explain about the failure because they learned it from YouTube. There are a lot of YouTubers out there. All you need to do is just press the subscribe button and they will be helping you with a lot of their speculation. So we have to be careful. Young engineers, forensic engineers who are looking at this probably would also want to agree that we will need to be careful in actually making any kind of assumptions until the final report is out. Now, coming back home, I've taken you to first to Italy and then to Taiwan, to US, and we are back home again. This is our condition with regards our condition in understanding our structures, some which are located in the marine environment. Otherwise, there are some which are probably suffering from some kind of defects that we don't really understand. But the duty of a forensic engineer is to look at the details and to actually find what is the root cause of the problem. What is the cause? Now, these are structures which have been designed, but they have been put into a very harsh environment. It's a marine environment which we consider as harsh, extreme. So the consequences we all know, it's all about corrosion. That will be the end product. And what do? What is our normal practice today? In our normal practice, what we do is we follow a certain path in our assessment or in our investigation to determine what actually is the problem. And then we rate it. We have damage classification scheme. This is the way we do things. This is where we are today. And if I summarize, then it basically boils down to this 5-step approach, starting from identifying the defect, classifying it, and then verifying, then you quantify, only then you rectify. So for those who are in this industry of doing condition assessments and finding out about failures or damages in concrete, I'm sure you're familiar with this approach. But things have to change as we move along because these are some of the test methods that we are currently employing. We have a series of these tests that are in place, and we normally use the different types of tests depending on the type of damage. And in analyzing, our approach to look at how can we change what we are doing today if AI or artificial intelligence and challenges in forensic engineering is something that we want to discuss. This is the second part of my presentation. I have just covered the problems, and now we go through the challenges. What are the actual challenges that we are facing today? But let's understand artificial intelligence first. Of course, there are lots of, there's a lot of information and there's a lot of materials in the social media, in the YouTubes. You can learn a lot from the social media, especially from YouTubes, on understanding artificial intelligence. I will not go into the details. I'm not a subject matter expert, like some people would want to claim themselves as subject matter experts, material scientists, top 10 material experts, subject matter experts. No. I have to be very frank here. As far as Industrial Revolution 4.0 is concerned, the little understanding that I have, I will quickly share with you so that I will spare you the pain of going through the complexities of what IR 4.0 is all about. It's all about the evolution of industrial production. So how are we going to relate it to construction, especially to forensic engineering? A quick run through the timeline. When we talk about the first industrial revolution, it was Industry 1.0, 1784. It was steam power and it was water, and then followed by 2.0, automation. It is all related to the manufacturing industry, nothing about construction. The third one was Internet of Things, and things improved with the connectivity. And the final one, this is where we are today, 4.0. Now, what's the difference between 3.0 and 4.0? If 1.0 and 2.0 is clear, then 3.0 and 4.0, what is the difference? As a layman, I understand only one thing. When we started in the beginning, all humankind worked from home. They did farming. That was industry probably 1.0 and before. Today, we are going to go back to that stage again where we all work from home. We have started to love to work from home. Thanks or no thanks to COVID-19, but that's the reality now. So, but then how does that relate to Industry 4.0? In Industry 4.0, we are going to make things happen between machines. Machines are going to communicate with machines. In Internet of Things, we communicated with the machines, but there will be a time where we will need to let machines to interact with the machines. And that's the difference between 3.0 and 4.0. And to put it very quickly, what Klaus Schwab, who is today called the father of IR 4.0, just because he coined this phrase, he says that technological revolution that is blurring the lines between the physical, digital, and biological spheres is nothing more than understanding why we studied chemistry, biology, and physics during our university days. That is why we are emphasizing on physics, biology, and chemistry. If you understand that, this concept, then we have understood what digital revolution, you may call it, or digital transformation, you may call, is all about. So to me, because I'm fundamentally an engineer, so I will just coin it as digital engineering. So who knows, maybe I'll be one day called a father of digital engineering. So by virtue of me just mentioning that this is nothing but digital engineering. In our layman terms, in engineers, we will call it, or we will term it as digital engineering. Now, moving on, very quickly again, I'm no subject matter expert, but this as much as I understand, what's the difference between artificial intelligence, deep learning, and machine learning? What is the difference? Now, when we talk about deep learning is all about when a model is something that is created, okay, and it is taught. It is all about deep learning. We make sure that the model learns, there's deep learning, and it is able to extract patterns from data using neural networks. Moving on, what is machine learning? Machine learning is the ability to learn without explicitly being programmed, meaning that there is a certain level of trust between the user and the machine when it reaches a certain level. And what is artificial intelligence? It is nothing but when machines start doing or taking over the role of human beings, they start to mimic human behavior. That is termed as artificial intelligence. So the question comes back again. One day, if forensic engineers, will they be replaced by robots? The answer is yes, possible, because when we actually make sure that the machines do deep learning, and if we ourselves don't do enough deep learning, then we are making room for robots to take our role one day. And as I understand, this is what I probably understood by deep learning. Deep learning meaning that you really need to go into the depth of what you want to know. You really need to go deep, and that's the meaning of deep learning. So very quickly, what are the challenges yet? Because when we have a problem, what do? Traditionally, what do engineers do? We learn from experience. And after learning from the experience, then we apply, we learn about the outcome. In the case of machine learning, thousands and thousands of X-rays or digitalized material is actually fed into the computer with the help of neural networks. They are able to recognize patterns, and lo and behold, they give you instant results. So what is this all about? It is about input data, we digitize the data, then we digitalize the data, and we create an AI model, artificial model, which extract patterns from data using neural networks. And eventually, the output, diagnosis and identifying precursor symptoms. This is the model that we are looking for now. Now, are our systems now that are in place, the traditional systems, are they able to, or are they capable of doing this yet? Let's go through the next series of challenges that we can see here. We will need to feed all this data into computers, into the model, so that they can actually generate and understand what we are talking about. This is the external face of concrete. Probably you can see some voids, but this is what is inside the concrete. So meaning that the computer has got a long way to go. The model has got a long way to go, even if we embark on deep learning just at the moment. And this is a classic example of carbonation. So we will need to actually train the model to identify what is actually wrong with this structure, and what is the most probable cause. So that's the extent of deep learning that we will need to look at, and these are some images of erosion damage on a bridge, and the different levels of leakages. How are we actually going to train our model so that it is able to distinguish between what is critical and what is not critical? So the question comes back again on the challenges. So these are the challenges that our structures are undergoing today. And a machine has to learn first to appreciate, understand what are the symptoms and how do you relate back to the cause. Finally, ladies and gentlemen, we are into the third stage of our presentation, that is, what are the opportunities? 5 steps to leverage AI in forensic engineering. We need to leave behind the past. We have to move on. We cannot be sitting on what we are doing and be happy with it. We have already had breakfast. We need to think about lunch and dinner. Embracing digitization, digitalization, and digital transformation. Okay, very high-sounding words, but I'll explain to you very simply. We need to work and create what is called a multidisciplinary dream team. We need to integrate current technology with sensor technology and BIM. You need to build trust, collaboration, recognition with all the parties. We need to advance innovative research and lifelong learning. And we need to move away from doing things which are analog systems. We need to move away from understanding only what are analog, for example, micrometer. Universities must move on. We cannot be using those old scales. We need to move on. The spring balancers have to be replaced by transducers, sensors. These are the areas that we need to challenge ourselves. And then now, lo and behold, we have got a different range of sensors. So these sensors can help in actually determining some of the parameters that we wish to know and connect it with the machines today. BRAG, for example, the YBhg is another ideal case, or the H2S gas monitor, which can be monitored remotely by remote sensing. And our test for carbonation probably need to move on to be something more sophisticated and more exact. So apart from drone technology, there is also the case of a magnetic flux leakage. There are opportunities because robots can now actually climb up these cables and detect what is wrong with the cables before a failure occurs. And then if we talk about embracing digitalization, what is digitalization, digitization and digital transformation? Very simply, digitization is fixing the past. Sorry for the pronunciation. It's pretty tongue twisting sometimes. Digitalization, focusing on the present, and digital transformation is creating the future. Like I said, I will sum it up by saying that it is nothing but digital engineering. Finally, we will need to look at forensic engineers together with the rest of the team as what I would refer to as a team, a dream team that will be able to actually understand structures better. And then the dream team will be able to put focus on actually working with collaborative partners and then establishing a system, for example, to look at how we can monitor things as they come along. So the future is going to be more towards how we are going to conquer the skies, all right? And then also to infuse clinical lessons that we learn from our real life cases, bring it back to classrooms. These are some of our challenges. And again, we need to move away from our old methods of doing work. This was yesterday. If we are today here and tomorrow, we will need to scale the skies. In conclusion, very quickly, we need to leave behind the past, and we need to actually invest in multidisciplinary approach together with emerging sensor-based technologies, and to have collaborative partnership, and eventually to embrace Industry 4.0. That's the way forward, and we sometimes feel that AI is a challenge, but looking at Japan, they are now racing, they are racing to hire 270,000 artificial intelligence engineers. This is the way forward. And as we move along, we will have to actually be very clear about our priorities. It is either we burn our tires or we scale the sky to get what we want. And eventually, for those who are keen to look at how they can actually explore the possibility of following a course, say for example, a master's program. This is one program that would be actually conducted by UITM. And lastly, but not least, like Steve Jobs says, stay hungry but not greedy, stay foolish but not ignorant, stay humble but not timid. And for forensic engineers, I will always have to share this with you: have more than you show, know more than you know, and speak less than you know. And finally, when in doubt, always apply first principles thinking, reasoning from first principles.
May the force be with you.
May the force be with you. Thank you very much, ladies and gentlemen.
Thank you, Engineer Panam Singh from RNC Technology Sdn Bhd for the presentation just now. Next, we will continue with the question and answer session. If there is no question, the floor would like to thank Engineer Panam Singh again for his excellent presentation.
Next, let us continue the session with our second presenter, Engineer Dr. Fairul Zahri bin Muhammad Habas from Public Works Department of Malaysia. He will present his paper entitled Reviving the Structure Through Forensic Investigation. Without further ado, please welcome Engineer Dr. Fairuz Zahari bin Muhammad Abbas.
Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajmain. Amma ba'du. Have you given a thought that the forensic engineering not only probing the results of a failure of the aftermath of an incident, forensic engineering is a very vast, very wide scope of engineering. In this case, what we're going to do, what I'm about to talk to you, is from the forensic engineering, we can revive the structure from the disaster or from the catastrophic incidents. This is Fairul from Bridge Design Division, Jangan Jalan, JKR Malaysia. Right, so my storyline begins with some introduction of the case. I'm going to talk to you about the forensic intervention, some of the material tests involved in the forensic intervention, the structural assessment involved in the forensics, not only the physical stuff, not only the visible inspection. Then we're going to talk about the way forward, some conclusion. Right, so what is the case? We have a project, a bridge project located at the stretch of Jalan FT 1744 Simpang Polai Lodging. It's a remote area. They call it Jambatan Sungai Lebih. So it begins construction in 2010, but was abandoned in 2012 and has experienced tremendous amounts of damage, extensive damage, particularly due to the monsoon in 2014. Let alone of the incomplete structure because of the incompetencies of the contractors and so on. The condition survey was carried out in 2016, and the need to continue to restore, to resume back the bridge to be completed was started in 2019 until the current time. So we have a bridge which was abandoned half through the process of completion, and was made, unfortunately, was incomplete in 2014. And the task in 2016 was come to restore back, to complete the structure. Where does the forensic come into the picture? Let's just look at the background of the bridge. It's a 5-span bridge constructed by the balanced cantilever method. It's a box segment that carries a single carriageway bridge. The foundation was commenced in 2010, but the contractor did not manage to complete the bridge. Only, some few of the boxes was completed. 4 piers and 2 abutments have been completed at site. This was in 2012-2014. And 2 pairs of segment was left cantilevered, hanging in the air, was constructed. 1 pair of segment was constructed at Pier 2, and 8 pairs of segment, balanced segments cantilever were constructed at Pier 4. Altogether are 5 spans. Each span for the cantilevering is 100 meters, with a total length of 420 meters. And some of the segments was left intact with the false work, particularly at the abutment B. Right. So in 2016, JKR, we are desirous in retendering the project to complete the remaining structure. We have to make the stretch of the road continue from one end to the other end. So as such, we required a condition survey of the structure. We need to assess the current condition of the structure before we proceed to complete the structure. So the structure required the condition survey to be carried out. Due to the aging and exposure to weather and flooding, it is required that the bridge to be analyzed properly and study the possibility of unstitched cantilever deflection, or the profile, extent, and degradation of the entire structure. This is where the forensic intervention comes into the picture. The bridge was left many years. Now we need to continue it back, restore into its complete condition. So the as-is conditions of the bridge, whether Jambatan Sungai Lebih, we need to assess it. So the forensic investigation is required to determine how much the residual strength, what is the actual behavior of the bridge at that current state condition. This all must be ascertained. When we talk about the forensic intervention, there are stages of works that to be assessed. It is not like it's a one shot of a magic work that you can assess. You know exactly what the current condition of the bridge at the fingertip. We have to do the desk study, recognition of survey, inspection and data gathering. Basically, this is all a physical work. Then we have to come back to the drawing board. We have to get back to the computer to do the structural assessment. And we have to look into also the hydrological investigations of the bridge. How much the hydrological impact to that bridge. Then we come up with a conceptual rehab or refurbishment method before we can continue to complete the bridge. So this is in general the process that involves for the forensic investigation. Right. What is happening to the bridge? What is the current state of the bridge? So the segments boxes are generally, from the visual inspection, that you can see it's still in a good condition, with some minor cracks and defect here and there. Corrosions of the exposed bar. We can see a corrosion of a top plate of the bearing. Some of the bearing has been grouted, been left abandoned. You can see some of the expansion joint at the abutment which were already installed, but subject to the aging and deterioration, it becomes worse for serviceability limit state. There were major shrinkage cracks all over the box girder. Of course, it's concrete, subject to the high humidity, the high temperature, and high the weather condition. All these things affects the characteristic or the properties of the concrete. So this recognition survey is for the as-is condition. Now the challenge comes to the forensic engineering. We have to assess the main part of the bridge, because this bridge is a pre-stressed type. So how much the tendons been affected, or were the tendons been affected, or they were good, or they were sound, or they just can manage to continue whatever has been intended. So for Pier 1, when we did the field survey, we did the conditional survey on site, we saw that Pier 1, so there's no tendon has been stressed. It's purely supported by the formworks, purely sustained by the rebar. Pier 2, there's no tendon was stressed. Pier 3, there were 3 tendons that were stressed. Tendon number 301, 302, and 303. It was stressed. But they were not grouted. Pier 4, 6 tendon was stressed. All these stressed tendons were left ungrouted. They were not grouted. So the bridge engineer knows that, the tendon which is not grouted was subject to some deterioration, some impacts of the environment, be left on site for many years. And we can see the empty duct without any bar threading into the duct. So the existing tendon were found yet to be grouted, but the good thing is no signs of water seepage into the tendon ducts that can cause the corrosion to the ducting. You see, when you have a fail, or when you have a highly deteriorated ducting, which this is the main carrying member of the box girder, something has to be done. So the existing tendon were found still in good condition. There's no signs of corrosion or pitting, and no signs of the slippage. The slippage we can see from the anchor head of the tendon. The forensic investigation used the techniques of a breakup to slightly jack or slightly core the box to inspect inside the tendon. You can see here the tendon which is ungrouted, and we inspect the level of a corrosion in the tendon. This highly stressed tendon, was left intact. So some of the tendon which is left without any tendon inside it was also inspected using the endoscope and using the a small monitoring inspection techniques that can be used to inspect the tendon. Then we need to assess also the material itself. So what we did, we do the core test. So we core certain part of the positions of the beam, of the box, at the pier, at the hammerhead, some parts of the column and the pile cap. We need to assess how much strength, the in situ strength of the concrete. So we did the horizontal core using the 75 diameter of an in situ core. We core the girder. We core the pier crosshead, the pier column, as well as the pile cap. So we can see the positions of the core here, the blue one and the red one. Right. Then we evaluate. See, this is all the techniques that we use using the high pressure cutter, and the position is crucial. Our designers determine where exactly we need to core so that we are not interfere with the clutters of bars, which is heavily reinforced in this box girder. The web in the top fiber and the bottom slab of the box girder. The coring at the crosshead is the most challenging part, where you have to very careful not to punch through into the heavily reinforced area. Of course, we know that the box girder with the hammerhead is the most part, is the highly stiffness area, the highly stiffness member of the bridge. So carry out inspection of all existing tendon that ensure that they are grouted and in good condition. If it's not grouted, we have to check whether the strands are corroded at selected hack open location. So we have to hack if strands are badly corroded and pitted. So we need to consider to proceed to detension the bar or the tendon, and we have to replace it accordingly. This is where the forensic judgment required a crucial intervention. The techniques to detension the bar, the post-tension tendon, and must leave also the duct in good condition for the future replacement of the tendon. So the compressed air was blown into the existing tendon to check whether they are grouted, and also to check for the ducting, the water tightness. Of course, when we apply a pressure one end, then we have to monitor the pressure on the other end, and we see how much the pressure dropped. If the pressure was sustained good, and we can conclude that the tendon or the duct is having a good water tightness. So existing tendon were exposed using small hacker to check the existing strand condition. So we do the coring test, and from the results, we found out that the strength of the in-situ cube strength of the concrete is far beyond what we expected. The design concrete cube strength for the box is 50. Majority of the in-situ strengths are beyond 50, more than 50. Whereas for the pier, the design strength of the concrete is 40 MPa, and the in-situ strength is more than that. So, from the assessment of the visual forensic intervention that we do on site, we see that the concrete compressive stress result indicate that the concrete strengths are all in order. The in-situ strength of abutment is ranging between 42 to 53 MPa, which is greater than 40 MPa, the design strength that is required for the pier, for the abutment. For the pier, it varies from 43 to 68 MPa, which is also greater than 40 MPa. The box girder, which has a design strength of 50 MPa, and the in-situ strength that we found out from the site, is ranging between 54 to 86 MPa. We did also the carbonation test, and the result shows that no carbonation detected in the existing structure. The carbonation is very crucial, where it will impede the performance of the rebar. Once the carbonation tests include or get into the concrete, it will affect the rebar and become corrosion. And the concrete become expensive, and the crack will form. So the chloride content test also, results show that the chloride content was within the acceptable limit. So once we do the visual inspection, then we have to come to the drawing board and we have to look at the analysis of the structure. Once we do the analysis, we also do some of the geometrical assessment of the bridge. So the analysis of the as-is structural form, we model it in 3 dimensions as per what is constructed on site, in line with as-is dimension by survey and site measurement verification. So the support stiffness has been derived using Piglet program, which has the global stiffness of for the pile cap, board pile, and different length of a pile with confirmatory borehole in each pier. So the section design of pile capacity has been calculated by spreadsheet. We do it separately. So the as-is structural properties such as in-situ concrete strength, pre-stressing detail, the creep properties, construction drawings, pre-stressing in-situ as result was incorporated into our model. So from the analysis result, so we need to predict what actually will be the deflection should the bridge not abandoned or was constructed as what been designed for. we need to find the actual position on site. Then we can compare to what actually the deflected shape. So for Pier 1, we see that the tip of the cantilever from the survey measurement we got on site was, out range by 10 millimeters and 11 millimeters. You can see from the diagrams here. So if we plot the reference point here, we can see the site measurement, which is dotted here. And from the analysis, we see that actually it's supposed to be slightly up rather than noding it down, which is give a negative camber. Similarly, what we do for Pier 2, we find where exactly the deflection or the camber positions of the tip of the cantilever, and we compare to the existing position on site. Of course, the one that's on site is off, in this case by, for Pier 2, because of the less number of segment. They required this 15 mm of deflection. So from here, let me go through every pier, because this is where the start of the cantilever in pier segment. Pier 3, so we were thinking of that, how do we going to continue back the bridge? So we have to make the adjustment to the next form traveller, to the level of the positioning of the form traveller when we advancing the segment once we start with the project. Pier 4 subjected has experienced tremendous amounts of level issues. The tip of the cantilever was out. This one 123 mm, 123.5 mm out of the position where it's supposed to be camber in the negative position, in a positive manner, which is deflection upwards, but instead the tip of the cantilever has deflected downwards. So the adjustment is to be made either for the form traveller and the pre-stressing. The amounts of pre-stressing that we need to be adjusted also been analyzed. We can modify the deflections of the bridge during construction by modifying the amounts of pre-stressing during cantilevering. Right. We also did the survey. We have to find the dimensions or the positions of the pier position. It was found that the existing bridge structure and the abutment levels are consistently 1 meter higher than the design level. This is what has been constructed on site. Probably due to the design change along the way during the construction. Then what has been constructed was found out to be 1 meter higher than the design level. So we propose to raise the road level by 1 meter to match back the finished road level as intended. So this is the results from the survey. Right. When we wanted to continue back the cantilever with the inherited damage or the defects, or in terms of the levels and positions of the tip, luckily we have a good strength in terms of the material, and some of the tendons also need to be minor modification. So we adjusted the pre-stressing through the correction of form traveller position in order to obtain the true finish road level. However, with the adjustment through the pre-stressings and the correction to form traveller, we still have a problem of getting the finished road level, the true road, the required road level. So how do we need to solve this? Is through the regulating with the premix. So we have to increase the thickness of the premix because we have the results of the modifying the processing force as well as the positions of the foam traveler have been exhaustively utilized. So the only solution that we can provide is to adapt with the additional thickness of premix. For example, for pier 1. So we regulate the premix on the left tip 50 mm, the center of the pier with 72 mm, and the right tip with a 60 mm of additional premix. So we propose to raise the finished road level by another 50. And we have to regulate the premix at the pier, at the right tip and the left tip. Similarly, it goes to pier 2. We regulate the finished road level with additional premix. For example, this one, for pier center, we have to adapt with the 74 mm of premix, such a quite substantial amount of premix. Let's look at the worst condition, which is at the pier 4. This is pier 3, the pier 4. Pier 4 experience severe condition where we have to regulate more than what we require, which is 129 mm of premix, thickness of premix. Normally what we do, we just adapt with the premix, we just design the premix to the maximums of 100 mm thickness, by 129 mm thickness, plus with another safety, can go up to 150 mm thickness of premix. So this will incur additional load to the structure. Something has to be done to take up the load. So from there, we can see what been gathered information from our assessment on site through the forensical assessment. We can see that from the core test, we can ascertain the strength. So from the test result, we can achieve the concrete design strength. And from the quality of the existing tendon, we have seen that there's no signs of carbonation and chloride attack. But we have a problem with the deflections of hogging, and then we can adjust this through the pre-stressing. However, the box girder bridge need to be strengthened with the additional tendons to cater for extra loading from the regulating premix. But the blister or the tendon or the position of tendons has already there. They were designed with that designated positions. So how do we put extra tendon into the box? Okay, this is. Then we analyze the additional. We analyze the additional load to the complete structure, and then we found out that this is the additional thickness of the premix. We analyze it, then we include the the unbonded external pre-stress to the box girder at the span number 4. Okay, here, position. This is where the unbonded tendon located in the span number 4. This tendon was designed to take up the additional load due to the premix in order to handle the tensile stress that affects the box girder at span number 4. So we have to include additional blister and additional tendon to the box, and we propose using the rebar drilling into the web, using the Hilti to anchor the external, unbonded external tendon. Then we find that the stress of the section within the allowable limit and the position of the foam traveler is ready to advance with the design deflection. So in conclusion, so this presentation demonstrates that the forensic process and technique involved in investigating the current condition of a structure, required is possible to restore the conditions of the severely affected bridge. So we propose to use rebar drilling to the web of the existing box girder to anchor the unbonded external tendon. So with that, thank you for your attention.
Thank you, Engineer Dr. Fairuz Zahri, for your presentation just now. Now we are open for Q&A session.
Okay, the first question, how much maximum premix allowed 129 mm to the bridge can take with external stand?
Right, so the additional load due to the premix on the span 4 need to be resisted by the additional external unbonded tendon. So we use a pair of external unbonded tendon. One pair of the external tendon consists of a 19 number of strand, 0.6 diameter, 0.6 of inch diameter, which has 1,860 MPa of a yield strength. So one side is 19 and the other side is 19. So we have two pairs, 38 numbers of a strand, tendons of a strand for two tendons, one pair of a tendons. So that will answer the question.
Okay.
Is there any question?
If there is no further question, the floor would like to thank Engineer Dr. Fairuz Zahri bin Muhammad Abbas again for his excellent presentation.
Aduh.
Next, let us continue the session with the third speaker for today's seminar. With the title of Parametric Study Using Forensic Method on Abandoned Cut Slopes on a Road Project, please welcome Mr. Zarul Azri bin Adnan from Khairi Consult, Sendirian Berhad to deliver the speech.
Okay, Assalamualaikum and very good morning to all of you who attend this seminar. And I would like to thank Mr. Chairman, and Ms. Moderator, and thank you for inviting me to present on the seminar today. Okay, I would like to introduce myself. My name is Zarul Azri bin Adnan. I am from Kari Consult, a consulting civil and structural consultant based in Sri Gombak, Selangor. Today I would like to present, this is the topic, the parametric study using forensic method on abandoned cut slope on a road project. We have carried out this study together with my team, as mentioned here, consists of me, myself, Zarul, Muhammad Daniel, Wan Aisyah, Hasliza, and Nadatul Zahra. So without any longer, let's go through to the presentation. Okay. This is the abstract. Okay, briefly, we have conducted this forensic study on an abandoned road project. The location of the project was located in eastern state of the Peninsula Malaysia. The proposed project travels through some rugged and mountainous terrain. So due to this, some cut slope construction has been involved in the site, but the project was discontinued and left abandoned for some time. The reason for the abandon were undisclosed. We don't know the reason. Due to this, the site was exposed to heavy rainfall annually. Due to this factor, some of the cut slope constructed has failed. And so with the approach of forensic study we have conducted, we find the best solution for the remedial and the proposed cut slope repair. Okay, this is a little bit of the project background. Okay, as I was mentioned earlier, the abandoned road project is part of Kota Baru Kuala Krai Road project, which linking the Kota Baru town in the northern region to Kuala Krai in the southern region in the state. The total length of the road is 10 kilometers. This particular 10-kilometer road is linking the Bukit Tiu, a small town in Machang, in the northern region, to Kampung Berangan Mednap, in the southern region of the state. Okay, as we have been told, the project has begun construction in June 2015, and the construction has stopped due to undisclosed reason and left abandoned since November 2018. It's about 3 years until today. The site has been abandoned. So due to this condition on site, a forensic study has been carried out by my team, beginning in April 2021 to study and to investigate the current condition of the abandoned site. From this study, we have identified 5 locations of the failed cut slope. However, in my presentation here today, only one location of the failed cut slope are going to be further discussed. Okay, this is the scope of the forensic study we have carried out on the cut slope. Okay, as you can see here, the forensic study consists of 3 parts. The first part is the literature review, second part is the fieldworks, and the third part is the analysis on the remedial works. Okay, as you can see, number 1 here, that study is part of the literature review, inclusive of the survey, drawing review, geological map review, and work program planning. This information was given to us by the related authorities. And number 2, number 3, and number 4 is part of the field works we have carried out. It consists of detailed site observation, inclusive of taking aerial photograph from drones with the latest technology available in the market. So we're able to get very nice aerial photograph using the drones. Also, we're taking some ground photograph at site. We did some measurement using measuring tapes on the slope features, and we recorded it in a form called proforma. Also, we analyzed the existing slope features. Everything that we have seen at the slope, we recorded it. And lastly, we identified the probable causes of the failure with all this information collected. Okay, the fieldwork also consists of geological study, which we engage with our geologists to carry out the study. It involves slope mapping, terrain classification and coding, erosion mapping, and hazard mapping. Also, the third part of the fieldworks, we did some soil investigation on the cut slope. The soil investigation involved deep borings and Macintosh probe. And lastly, we did the analysis, and we came out with the recommendation on the remedial works. Okay, this is the location of the abandoned road, the site project. As you can see, the pink colored line is the road alignment. You can see the road start at Bukit Tiu, a town in Machang, Chenesh 43225, towards the end of the Chenesh 53225 in Kampung Berangan Metnap. As you can see, the box colored in blue and red is the location, the 5 location of the slope failure. Location 1, 2, 3, 4, and 5. But in my presentation here today, I would like to discuss with you, to share with you the study we have done at location 2 only. This white line is Federal Route number 8, linking Kota Baru to Gomusang. And this is Federal Route 4. From the right-hand side is towards Pasir Puteh to Machang, and the left-hand side is towards Jeli. Also, as you can see from the slides, the blue shaded area, this is the floodplain area, as info received from related authorities. Okay, we also did some review on geological map. This is the map we abstract from Mineral and Geoscience Department of Malaysia. This is the geological map of Peninsular Malaysia. This is the yellow color line is the road alignment. It travels through the intrusive rock formation consisting of granite rock. Normally, this formation, the residual soil found in this formation is silt, clay, and sand. Also, some common characteristic we found in this formation. Also, in road construction, mostly we found out some boulders along the alignment, and due to the highly eroded slope surface, maybe probably due to the highly weathered granite. Okay, now we are going into the field works. The first one is the detailed site observation. This has been carried out by me and my team. Okay, as you can see here, the location plan of the slope failure. This is the survey data given by the authorities to us for our review and for our purposes. This is the location 2 cut slope as indicated by the surveyor. This is the landslide area. Okay, this is the aerial photo we have taken by using the drones. As you can see, this is the failure of location 2 cut slope. It is the 5 berm cut slope. As you can see in the background here, it consists of primary jungle. It was untouched jungle. Consists of wild vegetation, shrubs, and all. As you can see here, there is a river here. We call it Sungai Merekai. This indicates this is the lowest point of the area. In between 2 mountains, on the right-hand side is a mountain. Also, on the left-hand side is also a mountain. This is the road. This is the platform of the road. Consists of cut slope and some field embankment. As you can see here, some formation of gullies erosion has been formed on the field slope. Okay, this is the detailed aerial photo from drones. We taken using drones. As you can see here, this is the landslide that happened on the left-hand side of the slope. So number is number 1, number 2, 3, 4, and 5. Okay, at number 2 here, on the first berm of the slope, we observe there are severe real erosion has occurred. So as we climb up the slope, we observe only 3 berms of the slope are constructed with berm drain. Unfortunately, the 4th and the 5th berm, there were no drain constructed yet up here. So from our observation at site, we've seen that the water from the berm drain, the surface runoff from the berm drain, it flows towards the left-hand side of the slope, towards the failure scar. As you can see, the photo was taken on 7th of April this year. We did some deep borings or boreholes along the slope surface. Borehole number 22, 23, and 24 at the crest, at the bottom, at the toe of the slope, and at the middle of the berm. This is for us to identify the subsurface profile of the slope. So this numbering in blue circle is where I'm going to show in the next slide the ground photograph at each location. Okay, as you can see, this is number 1, location number 1 at the landslide area. This is on the right-hand side here, also at location number 1. As you can see here, there is a mark of water flow inside the failure scar. And this is location number 2. You can see this is the real erosion occurred on the first berm of the slope. This is probably due to no slope protection constructed yet at the slope. This is figure number 3, 4, and 5. This is the berm drain at the first berm, the second berm, and the third berm. As you can see here, this drain, the soil below the drain has been collapsed, and siltation has occurred inside the drain. In figure number 4 here, you can see the drain has collapsed together with the landslide. In figure number 5 here, you can see a lot of wild vegetation has grown inside the berm drain. This has disrupted the surface runoff flows in the drain. These photos is very important for us as our database, and we also did some measurement on site at each features we found out on the slope, and we recorded it in a form called proforma. Okay, this is the proforma that has been designed by our company, me, myself, and my team, consisting of geotechnical engineers, drainage engineers, road engineers. We discussed together to design this proforma. This is simple proforma design to suit the study. The information needed in the proforma is suitable for the study to be conducted. So this proforma keeps on updating this proforma based on the suitability of the project we carry out. Okay, as you can see from the proforma here, this is the sketch of the slope. You can see up here, this is the location, the feature type, the cut slope, feature number. We number the feature as number 44. This is like the ID to the features. Along the 10 kilometers road, we number every feature we found on site with this number. So this is number 44. It is located on the left-hand side of the road. Yes, you can see from the sketch here, this is the landslide on the left-hand side of the slope. The diameter of the failure is about 17 meters. And you can see the first berm here, real erosion has occurred, and the berm drain. And so we sketched the cross-section down here. The berm height is about 30 meters high, we measure the berm drain size. The size of the berm drain is 750 millimeters width with 250 millimeters depth. The slope height is 6 meter per berm, and the second to fifth berm hydroseeding has been carried out. Only first berm with no slope protection. And the second sheet is the information note down from our observation. As you can see, it stated the information needed are such as the slope protection, the failure mode, the drainage type, and all. Okay, then this is the summary of the site observation we have carried out at site. So this is the location, the characteristic of the slope, the feature number 44, and this is the condition as I have been explained earlier. The erosion, berm drain condition, intersector drain, no intersector drain has been constructed, and also no slope protection at the first berm. Okay, after all this information gathered, we identify the probable causes of the failure to the cut slope. Okay, as I was mentioned earlier, the site is located in eastern state of Peninsular Malaysia. So it's subject to seasonal monsoon every year, normally during November to January. And the site also has been abandoned for 3 years and exposed to heavy rainfall during this monsoon season. As observed at site, the drainage structure were incomplete and the surface runoff also flows towards the left-hand side of the slope where the location of the failure scar. So due to all these factors, with all these factors has caused the surface runoff to infiltrate through the cut slope that caused the weakening of underlying soil of the cut slope, with increasing in time and exposure to heavy rainfall annually, the slope will start to erode bit by bit and getting bigger and bigger with increasing in time, and then landslide has happened. We coming to the second part of the field works. We also conducted a geological study. We have engaged with geologists, specialists on this study, geological study, to study the slope condition. We have about 2 to 3 geologists working with us, together with us in this study. Because we need some information from geologists on their study as geological point of view in how they see the slope condition. Okay, from the study, our geologist has come out with slope map, terrain classification, erosion map, and hazard map. Okay, as this is as found out by our geologist, this is the slope map. As you can see here, this is all in color coded, the green to the red color one. Our geologists generate this map using computer software called ArcGIS. Okay, as found out by our geologists, the cut slope is a class 4 cut slope with more than 35-degree slopes. Also, the existing cut slope is excavated at minimum 1-to-1 gradient, which is equal to 45-degree slope. Okay, next one, our geologists also come out with the terrain classification and coding. As I'm not quite familiar because I'm not specialist, this is not my specialty here, but we work together with our geologists. We are incorporating this together in our study. Okay, however, as mentioned in the figure, you can see our geologist has come out with some codes to the slopes. As found out by our geologists, the slope is classified as 5B with small letter b. The first 5 means the slope is 35 degrees to 60 degrees. The first B, the capital letter B, means the slope is a side slope with straight formation. The second 5 is it is a cut slope with soil. The small letter B means it landslide has happened with diameter 10 meters to 50 meters. Okay, this is the table where our geologist refers to in determining the coding. This is from Department of Mineral and Geoscience. Okay, it stated here the slope gradient, the terrain code, the activity code, and the erosion instability. Okay, also, our geologists also come up with erosion maps. It is also in color coded here. From the description, our geologists found out that you can see the slope location 2, the landslide has happened here in the left-hand side of the slope, so here. And at the first berm, moderate to severe erosion has happened. Okay, lastly, our geologists come up with the hazard map. This is to determine the level of the hazard of the existing cut slope that has been constructed. As you can see here, at the failure location, the slope is classified as high hazard. So, from myself as engineer and our geologist, in our geologist perspective, from our perspective, we have come up with the same idea that the slope here demands remedial works to be carried out at the slope. Okay, next we come to the third part of the fieldworks, the soil investigation. We also engage with soil investigation contractor to carry out some SI works to help us to study the subsurface information of the cut slope. Okay, as I was mentioned earlier, 3 number of boreholes were carried out at the crest, or at the middle of the berm, and at the toe of the slope. From the result of the boring works done, the subsurface profile consists of sandy silt, clayey sand, and clayey sand. Bedrock of granite also was encountered at depth 7 meters at the toe of the slope to 15 meters at the crest of the slope. Here, this is the typical section of the subsurface profile where we have plot. As you can see here, the first layer is the sandy silt layer. This is clayey sand layer and sandy silt layer. This is the granite, the bedrock. The number of blow SPTN ranging from 5 to 36. Okay, then that's all the fieldwork we have carried out. Then we going back to the office. We did some analysis from all the information, all the data we have gathered from the sites using the forensic method. Okay, this is the remedial works design concept. First of all, the aim of the remedial work is to stop further failure from happening again at the cut slope. So we need remedial works to prevent further instability of the existing slope. And also, as presented earlier, the main factors of the instability of the slope is water and surface runoff. So the aim of the remedial works is to improve the surface and the subsurface drainage of the slope. Okay, the concept is, firstly, the slope is going to be reconstructed with slope gradient of 1 to 1.5, which is more gentler than the existing slope. And we put backfill soil, and we strengthen the backfill soil with geogrid. This is to help to enhance the stability of the backfill soil. Okay, next, the reconstructed slope to be incorporated with sand drainage blanket. This is the subsurface drainage for the remedial works for the cut slope. This is to help to discharge out the subsurface seepage. Also, berm drain at each berm is going to be reconstructed. Cascade intersector drain to be constructed along the edge of the slope to discharge surface runoff from berm drains toward the roadside drain. Also, cut-off drain is going to be constructed at the slope the slope crest to avoid surface runoff to infiltrate into the slope surface. Okay, this is the typical section of the remedial works design concept. As you can see here, this is the drainage blanket in thick line black color. This is the cut-off drain, the berm drain, roadside drain, the slope protection. We did hydroseeding. This is the backfill material, and this is the geogrid to be incorporated together with the fill material. This is to help to improve the stability of the backfill material. So the rock base is proposed at the bottom of the slope remedial. Okay, this is some design analysis we have carried out using a computer software called Slope W. We're using the modified Bishop method of circular failure analysis. Okay, we did the analysis in 3 cases. This is the first case, case number 1. We did the analysis on the original condition of the slopes, which is what we have observed at site. With the data from soil investigation, we model this model and we run the analysis. The factor of safety from the analysis we obtained was 1.108. This is the original condition. Next, case number 2, we analyzed on the failed condition. Of course, the slope has failed, the factor of safety is going to be lower. The factor of safety from the analysis is 0.78. And the last case, the case number 3, we did analysis on the slope remedial. This is the backfill material with the geogrid. The factor of safety from the analysis we get is 1.568. This is adequate and it complies with all the requirements and design criteria specified by related authorities. Okay, now we're coming to the end of my presentation. From all the fieldworks, from the literature review, the fieldworks, the analysis we have done, I am concluded that from the study that careful assessment and sufficient site investigation with approach of forensic method is very important to derive the causes of the failures, and it helps us to determine the long-term remedial solution for the cut slope repair works. Also, as we know, as presented earlier in my previous slide, water gives very big impact towards the stability of the cut slopes. So with approach of the forensic method we have carried out, we found out that the drainage system is needed to be improved. With the improvement of the drainage system, the stability of the slope also improve. This is happened by reducing the surface infiltration that causes the erosion and also the landslide. Okay, apart from the surface drainage, subsurface drainage also is plays very important part to drain out seepage water by using the sand drainage blanket. This will help to reduce the excess pore water pressure contained in the soil. With the lower water table, with lowering the water table, the slope will become stronger. And lastly, with all the analysis, with all the forensic works we have carried out, so remedial works using geogrid reinforced slope is a safe and workable approach for the long-term slope remedial solution. As you know, we as human beings are with limited knowledge. We try our best to rectify the slope failure. And we always pray to God that with us, so God will be with us in this work so that the slope will be stable and this will avoid the failure from happening again. This is all the knowledge and information that I can share with all of you. I hope it will benefit some of us. It will give you new information. And that's all from me. Thank you.
Thank you, Mr. Zaro Azri, for your amazing presentation. Now we are open for the Q&A session.
All right. The first question coming from MRA from YouTube channel. The first question is, what is the difference between natural soil and artificial soil?
Okay, natural soil is the existing soil we found out at site. The soil has been undisturbed soil. It is no construction has been carried out yet at the location. But artificial soil is the soil that we have disturbed. That means we imported the soil from other sources and we bring it to the site and we use it in the construction.
Thank you, Mr. Zarul.
Is there any other further question?
If there is no further question, the floor would like to thank Mr. Zaro Azri bin Adnan again for his excellent presentation.
Dear ladies and gentlemen, that's the end of our first half of the session today. We will have a break now until 2:15 p.m. Please note that the afternoon session will be commenced at 2:15 p.m. with the fourth presentation by our international speakers from Japan, Dr. Ashok Krishnan from Sinspective Incorporation. See you after the break.
Hai, saya Nur Alminti Muhammad Bahrul. Saya merupakan jurutera elektrik di Makmal Penyelidikan Elektrik Grade.
Assalamualaikum, nama saya Muhammad Afiq Betan Bicik dan saya merupakan seorang jurutera di Makmal Penyelidikan Struktur Konkrit dan Alam Sekitar.
Assalamualaikum, nama saya Siti Nur Azila binti Khalid. Saya salah seorang jurutera di Makmal Penyelidikan Mekanikal.
Hai, nama saya Syaran Kumar Nagendran. Saya adalah salah seorang jurutera di Makmal Penyelidikan Geoteknik.